Well, you know, I've never seen one of these in a box before. Transcom GBX4000 from 1981, using the Cybernet 002 F chassis, just like the real Amstrad does. This Fidelity 2001, Harvard 402 MPA, and the Mustang series. It's about the same as Mustang 2000. So I suppose it's got a Roger bleep. I think it's the 21st today, but it really doesn't matter. It's coming from a customer and has asked us to provide 2 power leads for us as well, which Mr. Chippy has manufactured. Oh good, I've got an instruction book to scan. And we've got an original mic. I might be tempted to do it with the standard replacement mic, and then we'll do that at the end. Inserts, bag, everything. How impressive is that? So it's a square round type which we make. So I'll tell you what, we'll power it up. Might have to be doing the usual crocodile clips. We'll power it up and see what it does. There we are. Our channel 9 switch is called monitor. So does it light up red when you... No, I doubt it, because it's got the TX light there, hasn't it? So is our standard replacement mic actually on the bench, or is it somewhere else? Or shall we be starting with using his? Oh yeah, we've got to do this. This needs redressing, doesn't it? And we'll start off with our mic. Good, so it's hissing. So I'll go to picture in picture, which hasn't appeared. There it is. And it is doing 3.1 watts, and it's got a Roger bleep. So usual thing, if I can't get it to do more than 3.6 watts, I'll change to ballast resistor for a heftier one. Kind of 2.95. Channel 1, 3.1. Back to channel 20. Check the current consumption. It's 1.49 amps, which is quite a lot for the output it's doing. Low power. It's preset in these, but let's see what it does. 200 milliwatts. Deviation. Wallow. It's 0.9 on this. So when we go inside it, we'll check it with the other test set. This might be lying today. We'll be doing the VCO. It's important on these sets. Let's see where we are frequency wise. It's pretty close, especially for 40 years old. 2779100. So with that in mind, we'll set the signal generator to 27791. Keep that error in place so that we're getting a fair test with the receiver. Let it go up slightly. Oh, here we go. And we'll plug in the test equipment. It sounds a bit strangled. And we'll plug in PA. Do the PA. Testing 1 2. 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 Making sure RF gains up and tones near the top. So PA, meter lamp, switches, sockets. So we'll go over to the SINAD meter and see what it's doing. 12 dB. Good grief, we're not going to improve this. 0.245, 0.25, 10 dB, 0.21, my goodness, this is a sensitive set, and 0.59. Making sure I'm in the right mode. Yeah, I am. Right, full squelch. This is the wishy-washy bit about this chassis. But I tell you what, it's currently 100 microvolts spot on. It is the letdown. Set threshold. Naught 0.28. That's excellent at the moment. Put S9 on, which is 100 microvolts for CB in the UK, and it is showing plus 30. So it needs, it's actually showing S9 as 31 microvolts, which is too generous. Non-transmit. We're on low power still. It bangs across. It's supposed to be between the red into the centre of the red zone. It's full scale deflection. Right. We will open it up. Make sure there's no crud on there. So the biggest problem is deviation. It's far too quiet. It's difficult to get this across, this deviation business, because deviation is how loud the set is transmitting, but it isn't when it gets to a certain point. Because it's the width of the signal, you start going into other channels. You don't become louder unless you're listening on a Fidelity 1000. Could knock 4 pence off for not having to take 4 screws out. Beautiful. No corrosion. There we go. Right, VCO. Select channel 1. can't remember whether it's floating earth or not. So I'll just put it onto a known earth point. Put negative onto that coil. Far side of that capacitor. Just see if I can find a service manual. I'll have to skip that for now. I'll have to print off that relevant page. So we'll go through to the transmitter. We'll do that later. I want to more or less try and get this done. So go to channel 20 and see if we can get more than 3.1 watts out of it. So look at the centre of the peak. Little gain there. There we go, 3.6. When that cools down, it'll be a little bit more. Right, we'll look at it on the other channels. Channel 40, 3.5, channel 1, 3.6. Now that will cool down and will be 0.1 more. Remember, I'm using a commercial test set. If you looked at this radio on a hobby type meter, it's probably doing 7 watts. I'm not even showing you all this. Wrong meter. Right, key it up now. Go up to channel 20. It's 3.6. 6 watts, 3.65 watts, 3.5 watts. Go to low power. And on low power it's now doing 240 milliwatts. And our transmit current is now 1.53. Draw quite a lot. Deviation. Wow, look, we're still getting tiny. I'll go on to the other test set. It looks like that's where we're taking a break because the other test set isn't on. So I'll just put it on. It needs to be on 20 minutes. Okay, I'm back with you, and it's actually 1.5. So that's far too low. Wallow. I'm just going to try it with the factory original mic. Wallow. Wallow. That's bit iffy. Let's just go to PA. Testing 1 2, testing 1 2, testing 1 2 3, 1 2 1, 1 2 1 2, 1 2 1 2, 1 2 1 2. Just go back to our standard replacement mic. That just might be lack of use and dirty contact. So I really need to sort out the plug on this one. Testing 1 2, testing 1 2. Yeah, we're certainly better on ours at the moment. I've gone and sat down and need to unplug it from the test set. Right, so having got a reading on that, we'll go over to the Marconi test set and just see what reading we've got on that, and we'll know whether it's lying today. Wow, it's about right now. So we can now say it was 1.5. It's now 2.2 to a peak of 2.5 kilohertz. Let's do this VCO. I've printed off the appropriate page. You know, you could say 2.7 watts. Now it's had a bit of a rest. So where are we? Channel 1 is there, and we are supposed to be on 2 volts. So just pop that down a fraction. One of the chassis that quite important on, you end up with channels dropping out, like at the top and the bottom, especially when it's very cold. It's going to transmit. It should also be 2 volts. 1.86. Back to receive, 2 volts, into transmit, 2 volts. Then we go to channel 40 and check it's still in lock. They sound like 4.5, never is. That's absolutely fine. Not bad drift after 40 years, is it? Okay, so that's the transmitter side. We just need to do the meter. Meter preset is there. We want it in the centre of the red zone, which is there. A bit less generous than it was. Let's do the frequency. On channel 40. Just check we're still correct with the Z red zone. We are. $27,79125. See if we can bring that up. can. Right, over to the receiver. So now we'll dial in the correct frequency, 27.79125. Switch the oscilloscope on. Put an S9 signal on, 100 microvolts. Put the inset picture to the oscilloscope, which is moved for some reason. Must be the mice. And we want maximum recovered audio. I feel in my bones this is wrong. But, you know, we'll see. Yes, it is out. It just sounded a bit strangled. Now that might have affected the sensitivity and made it worse. But that's sometimes how it is. Over to the SINAD meter. See whether we can get some sensitivity back. Fraction there. Squelch has come in. Let's go back on that first one. A bit more signal for the next. No, we're spot on. A bit there on the front end, nothing on the IF. Let's get a new reading. For 12 dB, it's 0.22. So I'm pleased about that because we haven't lost sensitivity, even though we've improved the clarity with the detector. 0.2, 20 dB. Strange, we've lost a bit there. Squelch. Now that wants to back off. Let's go to the attenuator. It's now correct to 100 microvolts. And let's see where the threshold is now. Change scales. .35. So I say the squelch can be really wishy-washy on these, and anything using this chassis. But on this one, it's very good. Just potentiometer check. They're all fine. Just need to set the S meter. So back to 100 microvolts. So now, it was oversensitive and it still is. There we go, S9. We're done. And what a lovely set. But he would have been disappointed with that deviation being that low. It would have been very quiet. Now all we've got to do is put the screws back in. So when you look at the sensitivity on this for 0.22 microvolts for 12 dB, you're hard pushed to get a new set doing that. I hear people on ham radio, oh I've had this radio, wherever they're on, talking on our repeater on 77s, talking about the HF band, saying oh they've got this Kenwood Icom Yaesu and oh they've had it 15 years and they're going to buy a new set because they think that buying a new set they're going to get better sensitivity, but you know they're not. Lots of stuff from yesteryear was more money. Right, I do want to sort that mic out though before we do it. I'll just do the test to the aerial. Turn the test gear off. And he's got half a watt more out of it. One nano Roger. Saturday afternoon, 4:30. Nobody on. Bit of interference. You'd think this set was as deaf as a post. 19 Roger. And of course it's got each Roger bleep. No, there we go. We'll just do this microphone, might as well do it on, turn this off, put that to one side. This microphone's been wanting the cable dressing. It's one I've made up and I, for some reason, forgot to put the sleeve in. And therefore, we've been using this as a test mic for the last 6 months and it's slowly been coming to a full stop and a comma. It's no good doing on the air tests and you've got rattly audio because of this. The easiest thing to do here is actually to cut it off because the wires are now too long. And I won't have to even bother looking at the wire colours. I'll just use my fingernails there to trim those. Right, remember to put the piece of sleeving on. It's easily overlooked, you know, you think, oh this is going to fit fine on this thickness, and then it migrates away. put an old Tate T500 business radio onto T500 series, I'm falling into the same thing, a 520. Onto 4-metre amateur this morning at the club meeting. So I've not finished it, and I'll show that, because there are people out there who might be interested. Because I only paid £1 for it on eBay, plus £10 postage, and for a 25 watt radio, 2 channel, but you're calling channel on one other, it doesn't matter, and it's a cheap way into good amateur radio. And 4 metres, you know, I've had 65, 70 miles on that kind of power level. So, and it's what I like about 4 metres, there's not many people on it. And so those who are on it tend to be more technical, which interests me. So, just follow the colours, and I've got a jig, you know, for doing all this, but I'm only doing one, aren't I? And it's only for me. This is a ROHS solder, so the red one, and the other black one's going to be the shield. Or is it? No, I'll have to look it up. I'll have to get some sleeving as well. But you can see what I'm trying to do. It's a matter of padding out the just here, so that when we put it back together, this sleeve's got something to grip against. This is heat shrink sleeving, so we'll leave it at that. I'll just have to look that up, because I don't know which one was black and which one was sleeving, so it doesn't matter. Sort it out, ready for the on the air test. So there you go, Transcom GBX4000 in its box. Absolutely fantastic performance, and we'll see you on the air test. Thanks for watching.